Hello, good morning dear students. So today is 21st of August and today we are starting homogeneous differential equation, okay, which is exercise 9.6. Now yesterday in the previous video I have uploaded an introduction part of homogeneous differential equation, how to identify homogeneous differential equation. I hope you have gone through that video and I hope now you can understand what do we understand by a homogeneous differential equation. Okay, even though I'll give you a short understanding of homogeneous differential equation out here. A differential equation will be given to us, dy by dx is equals to something. Now to identify whether it is homogeneous or not, we'll have to see the powers. Okay, what is the power of x? 1. Power of y? 1. So the power in the numerator is 1 if it is addition sign. Okay, I'll come to other questions also so that you'll be clear more. But for the time being, you understand x to the power 1, y to the power 1. So hence the power in the numerator is 1. Okay, we are not going to that lambda process. Okay, f of lambda x comma lambda y. This will take a long time. Lambda to the power n f of x y. Okay, I'm not going through this process, but whereas I'm going through this process, which is very quick and easy to identify. Okay, so a differential equation will be given to us. To identify whether it's homogeneous or not, we'll see the powers first. X to the power 1, y to the power 1. So the power in the numerator is 1. Okay. Denominator also, if you see, the power is 1 because it is x to the power 1. So if the powers are equal in the numerator and denominator, then we can tell this equation is a homogeneous differential equation. Okay. So one of the simple way to identify HDE or not is this. Okay, see the powers in numerator and denominator. Okay, now let us keep it as equation number 1. And now as we have identified it is an HD, so we have to write down here equation 1 is a homogeneous differential equation. Now we have to follow the steps. Step number 1, give it as equation 1 and identify whether it is HD or not. If it is HD, we'll have to write out here equation 1 is HD. Step number 2 is very, very important. For all homogeneous differential equation, the substitution will be let y is equals to Vx. This is one of the important substitutions that we have to make. Alright, y is equals to Vx. So y is equals to Vx will be our substitution, where v is not a constant, where v is also a function of x, where v is also a function of x. Okay, so when I take the differentiation now, we have to use u into v rule. Okay, so differentiating with respect to x. Alright, so this was step number 1. Step number 2 is to make the assumption. Now step number 3 is to differentiate this. Okay, so dy by dx, as I told you, v is a function of x, so u into v rule, v d dx of x plus x d dv of dx. So therefore you will be getting the value for dy by dx as v plus x dv by dx. Okay, so hence I got the value for dy by dx as v plus x dv by dx. Now what will I do? I'll put this value in equation number 1 in the left hand side. Okay, therefore from equation 1, what is the value for dy by dx? V plus x dv by dx, which is equals to x, keep it as x, plus, according to assumption, what is the value for y? Vx. So this is Vx and then divided by x. I hope you all are understanding this. Alright, so now what happens is in the left hand side we can take x common. So this will be implies that sign, implies that v plus x dv by dx. Please take your x common. So 1 plus v divided by x. So what happens out here is x and x gets cancelled out. So therefore we will be getting v plus x dv by dx is equals to 1 plus v. Okay, so far I'm getting this much. Now the next step is easy. We can cancel v and v on both the sides. Okay, so I hope I can clear this. Please pause the video and note it down. So this implies I'll take v to the right hand side, so x into dv by dx is equals to 1 plus v minus v. V and v gets cancelled out, so x dv by dx is equals to 1. Now what to do? The same old thing that we have learned in separation of variables, so cross multiplication. So dv will be is equals to dx by x. Okay, now it has been separated, so now what we can do? Integrate both the sides. So we'll have to write integrating both the sides. So integrating both the sides, we will be getting integration dv is equals to integration dx by x. So integration of dv is v, integration of dx by x is log x and then constant c. By the way, what was the value for y? According to assumption, vx. So what will be the value for v? Y by x. So therefore this will be y by x is equals to log x plus constant. Okay, now cross multiply. So y is equals to x into log x plus c. So which will be our final answer. Okay. So once again, if you go through it, the first step is to identify whether it's HD or not by looking at the powers, numerator, denominator. Step number 2, assumption y is equals to vx, which is same for all homogeneous differential equation. In all the question we have to substitute y is equals to vx. Third step, differentiate and find the value for dy by dx. Fourth step, to put the value for dy by dx in equation and also the value for y. And the fifth step is to separate, and then the sixth step is to take the integration, and then you'll get the answer. And finally put the value for v. Okay, so pause the video and now note it down. Alright, the next one I'm taking is question number 3 part 2. So since dy and dx are in the same side, so I cannot do directly. Okay, so I have to take it to the right hand side, one of them. So I'm taking the second term to the right hand side, it becomes positive. Okay, now please write in the form of dy by dx. So dy divided by dx is equals to x plus y divided by x minus y. Let us identify and give it as equation number 1. Let us identify the powers. The power of x is 1, the power of y is 1, in between there is addition, so hence the power is 1. The power of x is 1, the power of y is 1, in between there is subtraction, the power is still 1. Okay, only if there is multiplication the power will be 2. I will tell you in that when the question comes. Okay, but for the timing, plus and minus, the power of x is 1, the power of y is also 1. Similarly, x is 1, y is 1, so hence the powers are equal. The power in the numerator throughout is 1, the power in the denominator throughout is also 1, so hence the power is equal, so which implies equation number 1 is a homogeneous differential equation. Okay, once it is a homogeneous differential equation, the substitution is always y is equals to vx, where v is a function of x. When differentiate, you will be getting the same value, v constant, differentiation of x1 plus x constant, and differentiation of v is this. So the same value you will be getting this much. Now the same step, what to do? From equation number 1, from equation 1, in equation 1, sorry, I'll put the value for dy by dx as this. This is equation number 1, so put the value for dy by dx, v plus x dv by dx, which is equals to x, keep it as x, plus y. The value for y is vx, so replace it by vx divided by x minus vx. So which implies v plus x dv by dx, x common 1 plus v, right, x common 1 minus v. I hope now you're understanding. X and x gets cancelled out, so therefore v plus x dv by dx, which is equals to 1 plus v divided by 1 minus v. Okay, so now what we'll do is we'll try and solve this and make in the form of separation by variables. I'll take v to the right hand side, okay, and I'll show you the steps. So pause the video till here and note it down. Alright, so from here I've told you to take v to the right hand side, it becomes minus v. Please take the LCM. LCM as 1 minus v. So 1 plus v minus v into 1 minus v. Open the brackets. Minus v plus v square. V and plus v and minus v gets cancelled out. So therefore x dv by dx is equals to v square plus 1 divided by 1 minus v. Okay, so I think so till it's fine, and now we will separate by cross multiplication. 1 minus v divided by v square plus 1 into dv is equals to dx by x. So this cross multiply into dv and dx by x. Now it has been separated, so hence I can now put the integration sign. Okay, so therefore the next step will be to integrate. The right hand side is very easy, it is log x, but the left hand side we will do term by term. Okay, so separate left hand side, we know how to do, it is not a new thing for us. So 1 by v square plus this is 1 square dv, I am separating a term by term, minus v by v square plus 1 dv is equals to log x. Since the integration is log x, I am writing log x. Okay, I hope you identify the integral, the standard integral 1 by a tan inverse x by a. So a is 1, so hence 1 by 1 is 1, so it is only tan inverse v. Alright, minus, if you substitute denominator, see again the same thing out here, the power in the numerator is smaller than the power in denominator. This is the case to substitute, isn't it? So if I substitute this as any of the variable, I'll be getting the numerator, but here it will be 1 by 2 and log of v square plus 1 is equals to log x. And then finally we'll put the value for v. What was v? See, y is equals to vx. So what is the value for v? Y by x. So therefore this will be tan inverse y by x minus half log y square by x square plus 1, okay, and which will be is equals to log x and then plus constant c. Let us keep it till here. Okay, so pause the video and note it down. Alright, if you check the answer, you won't be finding the same answer, but there's something different out there. The reason is that, see, you can keep your answer till here also, okay, but the author has simplified further. So what we can do is we can take the LCM, please take the LCM, and now you have to use the formula of log of a by b. So this is tan inverse y by x, alright, minus half, and this will be log of x square plus y square minus log of x square, okay, is equals to log x plus c. Now what happens is, since it is log x square, this 2 comes as the coefficient, and when you multiply with half, this 2 and 2 gets cancelled out. Alright, minus and minus will be plus, so log x and log x actually gets cancelled out. So that's the main, reason behind this. So I'm going to show it very quickly to you all. Minus half, because the video will be lengthy. Tan inverse of y by x, I will quickly with this. Minus half log x square plus y square, right? Minus and minus will be plus, and this is half, okay? Log x square will be 2 log x, right? Use the formula, log x to the power n. This is the power. This is your power, so it will be 2 log x, which is equals to log x plus c. Alright, this 2 and 2 gets cancelled out, and now if you see out here, this log x is plus, this log x is also plus, so when I take it to the right hand side, it will be minus. So log x also gets cancelled out, and your final answer will be somewhat like this, okay? Tan inverse y by x minus half log x square plus y square is equals to constant. I hope this is the answer at the back. Yes, so this is your answer. You can take this to the right hand side, it will be positive, okay? But the actual thing is to do the things properly. The examiner will not see this final step, okay? If we can do, very good, but the examiner will see, yes, whether he or she has understood what do you mean by HD or not. Okay, and then what was the substitution that he or she has made. Okay, after that, putting the values and then separation of variables. Okay, and after that, taking the integration. So those are the things that the examiner will be interested in seeing rather than seeing your answer. Okay, so as far as you can simplify it, please simplify. Okay, many of the students are asking me, so I'm not giving the correct answer at the back. Okay, I'm just looking at the steps. Yes. So that is the important thing out here when it comes to differential equation. Okay, so pause the video and please make a note of this.